We start with the basis of graph sketching. We start with the axis, horizontal, vertical axis, usually xy, and don't forget your origin. Your intercepts, label them xy intercepts. Then turning points, especially for a quadratic graph, minimum, maximum, or stationary points of inflection, label them as well. For the H2MS students, only the asymptotes, draw them, label the equations, and lastly, for everyone, once you're done sketching the curve, label the equation. Moving on to gradient definition, rate of change of y respect to x, vertical change over horizontal change, rise over run. As some of you might have heard it before. Basic graph, y equals to k, x equals to k, horizontal line for y equals to k, vertical line for x equals to k. Gradient of y equals to k is 0, gradient of x equals to k is undefined, usually equated to infinity. Linear graph y equals to mx plus c, m is the gradient, c is the y-intercept. So it's basically a diagonal line going upwards for positive gradient, positive m, doing downwards if negative gradient, negative m. Moving on to quadratic general equation, ax squared plus bx plus c. If a is less than 0, you get a sad face. A bigger than 0, you get a smiley face. If y equals to ax minus alpha times x minus beta, where alpha and beta are your two roots of the equation, your x-intercepts. Turning point, when you have this form, is basically at x equals to the midpoint of the two x coordinates. If you have ax minus gamma whole thing square, then simply you have only one intercept, which is also the turning point, which is at gamma, comma, 0. If you have completed the square formula, plus minus ax plus h squared plus k, simply your turning point is at minus hk, just like x plus h squared becomes 0. Cubic graph ax cubed, basically going through origin, and if you have a bigger than 0, a less than 0 is just basically opposite. If y equals a over x, basically the two corners, if a is bigger than 0 or a less than 0, will be take out the other two corners as well. Ax squared, now you don't take the two corners, in fact you take the same side. A less than 0, you'll be below the x-axis, a bigger than 0 will be above the x-axis, if the shape is rather similar. Exponential graph, k bigger than 0, you'll be going upwards, k less than 0, you'll be going downwards. Moving on to the cousin of the exponential curve, the logarithm curve, basically increasing at a decreasing rate, intercept 1, 0. Then we have the trigonometry curve, sine, cosine, tangent. You need to know that sine and cosine take the range of values of -1 to 1 inclusive, tangent, negative infinity to infinity. Key ideas, amplitude is at a period 360 degrees over b or 2 pi over b. Now, if you look at the sine curve, basically a camel hump sort of curve, amplitude is from the maximum and minimum to the x-axis respectively. Alright, and take note of the values, critical values, 0, pi, 2 pi will give you back 0, pi over 2, 3 pi over 2 will give you 1 and minus 1. For a cosine bx plus c, we let c equals 0 now, critical values, 0, pi over 2, 3 pi over 2, and pi. Alright, pi will give you back minus 1, 0 is 1, pi over 2, 3 pi over 2 would be 0. Of course, divide by b if you have a period of 360 degrees over b. Tangent looks like that, a bit different now, because now you have what we call by undefined values at x equals to pi over 2, x equals to 3 pi over 2. Alright, of course, if you have bx, then it's 3 pi over 2b, 3 pi over 2b. Basically, that is for the trigonometry graph. Moving on to our modulus graph, we have mod x, idea, negative x becomes positive x, therefore negative x side will take the values of the positive x side. So basically retain whatever that's in the positive x side and then reflect about the y-axis. So if we look at this linear curve, we just delete whatever that we had on the negative side, then repeat and reflect the positive x side. Now we move on to our modulus fx. Idea is that you only get back positive y values, so any negative y values will become positive. So reflect the negative y values about the x-axis. So looking at this quadratic graph, we have this negative portion, just need to reflect about the x-axis, then we have a hump that goes upwards instead of going downwards. So that will be the resultant graph. So the graphs involves basically only 3 types of graphs that you need to know how to sketch for the moduluses: linear graphs, quadratic graphs, and your trigo graphs. For our conics, we start with the parabolas. The first equation is the quadratic equation y minus k equals to ax minus h whole thing square. And the next type is the a y minus k whole thing square equals to x minus h, basically a c-shape if you have a bigger than 0, inverted C shape if a is less than 0. Vertex point h, k. For circles, the general equation is x minus h squared plus y minus k squared equals to r squared. Take note of the plus sign. Another one is x squared plus y squared plus 2ax plus 2by plus c equals to 0. Convert the second to the first equation to find the radius. Center, hk for the first equation, minus a minus b for the second equation. Radius is simply r. Now take note, coefficients of x squared and y squared are the same for it to be a circle, and usually convert it to 1. Ellipse, x minus h squared over a squared plus, take note the plus sign, y minus k squared over b squared, and take note equals to 1. General equation, alpha x squared plus beta y squared plus cx plus dy plus f. Again, to convert second to the first equation, just convert the right hand side to b1 after completing the squares. Center is simply at hk, and that is very important because with the center, you're able to calculate the topmost, bottommost, rightmost, and leftmost points depending on values of a and b. Hyperbola, similar equation, but now you have a minus sign, and again, right hand side equals to 1. If x minus y, you get a east-west opening hyperbola where the center is still hk, and the vertices of each parabolas, it has a distance from the center of a, and they're all in the same horizontal line. For the second equation, where it's now y minus x equals to 1, so y over b squared and x over a squared is now a north-south opening, and your center is still hk, and the vertices of each parabolas will differ the center by b, and they all lie in the same straight vertical line. General equation, alpha x squared plus beta y squared plus cx plus dy plus f equals to 0. Again, convert to either equations is in above, either x minus y or y minus x. Lastly, for parametric equations, do take note of the range of values of t used for the graph. If there's a restriction to it, you have to take note. Otherwise, you might sketch the wrong graph by either sketching too much, too little, or the wrong portion of the graph. Alright, for parametric equations, either use your GC to sketch, or if the question requires you to manipulate and obtain Cartesian equations. Sometimes trigonometry identities have to be used, either Pythagoras theorem or the double angle formula. Regardless, treat it as a normal graph, sketch it as per normal, and this is it for our graphs crash course.